Chapter 11, Section 1 in the 8th grade note-taking guide is entitled Simplifying Algebraic Expressions. So this is in large part going to be a review here because a lot of what you're going to see here in Chapter 11 is going to be about solving equations. We've already spent a lot of time over the last 2 years talking about solving equations. So a lot of what you're going to see is going to be very familiar to you, but it's going to be a good review because a lot of what you're going to see on that I-STEP test coming up is certainly going to be some type of solving equations and simplifying expressions, which is what Chapter 11 is all about. So let's go ahead and start off with the definitions here. We've got the definition of a term. Term, those are the parts of an expression separated by plus or minus signs. The parts of an expression separated by plus or minus signs. Like terms, two or more terms that have the same variable raised to the same exponents. Two or more terms that have the same variable raised to the same exponents. Equivalent expression. Those are expressions that have the same value for all values of the variables. Expressions that have the same value for all values of the variables. And to simplify is to perform all possible operations, including combining like terms. To perform all possible operations, including combining like terms. All right, so let's go ahead and take a look here at number 1. In number 1, they're simply asking me to combine like terms in the expression 14a minus 5a. Now remember, when we're talking about combining like terms, we can only combine terms if they have the same variable and if that variable is being raised to a similar exponent. So here where I have 14a and 5a, I can put those together because they both have a. But if one of them was a squared, let's say it's at 14a minus 5a squared, then I couldn't combine because one of them had a would be to the first power, and the other one had a, which would be to the second power. Can't combine them unless they have the same exponents. So 14a minus 5a I can do, because they both have a, we'll combine them by doing exactly what it says here. Since there's a subtraction sign in the middle, I'm going to go ahead and subtract. If I have 14 a's and I take away 5 of the a's, I end up with just 9 a's left. So 14a minus 5a must reduce to 9a. All right, number 2, we're combining the like terms in 5t squared plus 7p minus 3p minus 2t squared. Now obviously there's more here, and there are some things that are going to stay separate here. We've got the 5t squared and the 2t squared. Those can go together because they both have t squared in them, which is why they're both circled. But then you can see we've got 7p and 3p here, and those are both boxed in because I can combine those with each other because they both have p, but I cannot combine them with these things out the front and the end here because those have t squared in them. So the p and the t squared will stay separate. So we'll combine them exactly though using the operations that it lists. So here I've got 5t squared minus 2t squared. That's going to go together to make 3t squared. And then I've got 7p minus 3p. That's going to go together to make 4p's. So I end up with 3t squared plus 4p. All right, in number 3, we're asked to simplify 6 times 5 plus n, in parentheses, minus 2n. Now this question is a little bit different, but hopefully it's sparking something in your mind right now, because as you can see, we've got that number in front of a set of parentheses. As you know, when we see that number in front of a set of parentheses like that, that's always an indicator that we're about to use the distributive property. The distributive property is when we take the number that's in front of the parentheses and multiply it through to the things inside the parentheses. So that's going to deal with the 6 and the 5 plus n part. Not the 2n part because that's all separated. It's not in parentheses. It's totally separate from that. So 2n isn't going to be playing into the distributive property part here. So let's go ahead and take care of the 6 times the 5 plus n. I've got to take the 6 and carry it through to the 5 here. And I have to take the 6 and carry it through to the n, which is what they've shown you they've done right here with the 6 times 5 and the 6 times n. Well, obviously we can simplify that a little bit because we've got 6 times 5, which is changing into 30, and 6 times n, which is changing into 6n. And then this 2n here at the end, the minus 2n, I haven't done anything with that because there's nothing to do with it because it wasn't involved in that distributive property. All right, so we'll simplify because, of course, 6 times 5 is changing into 30. We can write 6 times n more compactly by writing 6n, and then I'm subtracting 2n. So the 6n minus 2n part, that's going to go together to make 4n, and I've still got the 30 in front, 30 plus 4n. You can't combine it past that point. The only way you could combine 4n with something else is if it had n in it. We don't have anything else here that's got n in it, so 4n is just going to have to stay separate from 30 altogether. Now, in number 4, we see just a touch of solving equations, but it's really more about simplifying and combining like terms than it is so much about the solving the equation here. We've got x plus 3x equals 48. All right, so we're going to put some things together here. I have x and 3x. Well, those can combine, of course, because they're both x. If I give you an x, and then I give you 3 more x's, of course that means I end up with 4 x's. So that's going to give me 4x equals 48. And now that I've simplified, combined like terms, now I can go ahead and solve the equation. Now we've been doing solving equations for the better part of 2 years, so you know exactly what I'm about to do here. I'm about to say keep the variable x on the left, correct. Keep the number 48 on the right, correct. So the only thing we have to move here is the 4 because it's a number and it should go on the opposite side. So as far as moving the 4 here goes, I'm going to divide both sides by 4. So I've got 48 divided by 4. That's going to change into 12. So x has to equal 12. And of course we can check that. 12 plus 3 times 12, otherwise known as 36, equals 48. All right, so let's go ahead and take a look at the check it out examples here. Number 1, where we're combining like terms, 5c plus 8 minus 4c minus 2 minus c. All right, well, we can simplify that. That's not too bad. We've got 5c minus 4c's, which is what they're listing right here. Well, if I've got 5c minus 4c, that's going to give me 1c. And then I'm going to be able to take away this c because it's also a like term because it just has c in it. But if I have a c and I take away a c, I don't have any c's left. So as you can see, there's no c's in the answer because it simplifies to 0c. The only thing that's left then are the integers, the 8 and the 2. The 8 and the 2, of course, simplify to make 6, which is what you see right there. All right, number 2, we're going to go ahead and combine the like terms again here. So we're going to take a look here. We've got the 9d squared and the 4d squared here. Those can go together because they both have d squared in them. And I'm going to do exactly what it says. So since it says minus in front, I'm going to subtract. 9d squared minus 4d squared is 5d squared. And then I'm going to hit the c terms here. I've got the 7c and the 2c's. Those go together to make 5c's. And again, we put those together exactly how it would be 5d squared plus 5c or 5c plus 5d squared. Those cannot combine because they are not like terms. That's as far as we can go in solving this question.